All right, everyone. Thanks for watching. This is going to be a video about sine and cosine. Now, you do see a circle here. This is to mimic the unit circle. I made it a little bit bigger. It's up to 5. The point is, as you go around, you have a triangle formed. As you go through all the quadrants, you have a triangle always, always, always. Why is the koala there? Well, he's there so you don't get stressed out, okay? Because people get stressed out when they see trigonometry. So the idea, again, is that wherever you go, wherever this koala goes, there's a triangle formed. And the sine curve is a measurement of the height of that triangle. Okay, we've gone over that in a different video. We don't have time to go over that all again. We're going to go back. We're not going to go back into the triangles. We're just going to focus on the graph. Well, where is he at 0? Well, your height is 0. And as you go up to 90 degrees, your height goes all the way up to 1. And then you go back to 0. And then down to -1. And then back to 0. So you do a full rotation from 0 to 360. A full rotation from 0 to 360. All right. Okay, so here's what I've got on this graph is the sine curve, but I only mapped it out from 0 to 2 pi, so that's 1 revolution. Okay, again, we said 0 to 360. That's the same as 0 to 2 pi. Again, the idea with that is that's the koala. From 0 to 360, he goes up, he goes down, and he's back to 0. Up and down, back to 0. So what are we going to do here? Well, we went up and down. So let's get the equation for the circle. And equation from circle from Math 2 and just from our previous videos is x squared plus y squared. Dang it. Y squared, sorry about that, equals 1 squared, or just 1. And the whole idea is that every point on the unit circle, as you picture, as you go up to 90, that's when he's up here at pi over 2. That location on the unit circle would be also at 90 degrees. When you get over to here at 180 or at pi, that's when you're back to 0. When you're down here at the bottom point, dang it. When you're down here, now you're at computer, I'm going to throw you. There you go. 3 pi over 2 minus 1. Okay. And then 2 pi is the finish. So these are the key points of your unit circle. Okay. As it goes up and it goes down, that's 1 cycle. Okay. Now, if only things could be that easy, they're not. What we're going to do then is we're going to add to it. That's 1 cycle of the sine graph. If you look here, I have several cycles of the sine graph. So it goes from 0. It doesn't end at 2 pi. That's just 1 cycle ends at 2 pi. It goes again and will end up at, that's that one, 4 pi. 1 cycles all the way to there. 1 cycles all the way to there. So that's 2 cycles ends at 4 pi. That's all the way up, all the way down. All right. What they next do with you is they say, well, what if we put a multiplier 2 times sine of x? And you should notice this graph is now twice as high. But the zeros are still the zeros. So once you know your regular sine curve, you can stretch it and let's do that again. Let's copy that so I can save some time. Paste that. 3 sine of x. Okay, so now you got a 3. It's up at 3 instead. Paste that again, and let's put 4 instead. Paste that again and put 5 instead. See how many colors they have. I'm going to edit these and change the colors. By the way, you should try all this on Desmos. It's a lot of fun, and you'll learn it well. And you'll be able to use it for your next class next year. Okay. So take a look at that. It's like your stretch. We call it a vertical stretch. Having a number in front of here is a vertical stretch. So having an a as our variable, I'm going to add a slider here. But I'm just going to go from our 1 and then we'll go higher. Okay. We'll go all the way up to what was our highest was 5. So we'll go 1 through 5. But I'll step it up by 0.2s each time. And it'll go do. And then I'll change the color. Make that a dashed line. That'll be our black one. So you can see how it's stretching and then it's shrinking. Okay, so that's how you can see A is actually a vertical stretch. Again, the variable we use is A, and that's a vertical stretch. It sort of looks like there's movement, like there's a moving pile of ants or a line of ants. All right, so that's how, but you notice the zeros don't change. It stretches the vertical points, but not the zeros. So that's one type of adjustment we can do to the graph. Okay. The next thing we can do to the graph is we can change the number in front of the x. That's what we call a b. We use the variable b because we already used a in front of the sign. So depending on where you put your multiplier, that changes it. Now, we didn't have this before, so this is new. B changes the period. So take a look. This is 0 to 2 pi. That's 2 pi right there. When I go here, it's harder to tell, but that's 2 cycles. If I take off this one, now you can see that's 2 cycles. If you go to here, that's now 3 cycles. Go to here, that's now B cycles, 4 cycles. We could put 5 cycles, 6 cycles, 7 cycles. We can put any number of cycles in there. Okay. I'm going to change this up. I'm going to change this up to 10 cycles. And you're going to see it step through. More cycles in the same amount of time. More cycles from 0 to 2 pi. God, dang it. That's 0, 2 pi. There it is. See if we can put a point there. Okay, that's staying at 2 pi 0. We're changing the number of cycles. Again, that's 3 cycles in there. 2 cycles. 1 cycle. So as you increase B, you're increasing the number of cycles. The other way to see that is calling it a vertical compression. It's like an accordion. It's getting squished. It's getting squished in the middle. It's like a spring. It looks like a spring, maybe. There's different ways to think about this. Compressing a spring or stretching out a spring. Compression. Stretching it. Okay. Questions? The next thing we could do is we could put a number C inside. So again, we put a number, so far we put a number in front of there, in front of the X, or now we're subtracting it from the X. Okay, and what this does, it looks like it moves the graph, it shifts the entire graph. The graph is not compressed, it's just shifted. So it's the same exact graph cut and pasted to a new location. So what you're doing is you're changing where does it start. Okay, negative 4.3 because x minus c was negative 4.3. So that's my new starting point. Okay, so it changes where it starts. And again, one cycle of sine would be like all the way up, all the way down. So one cycle is from a 0 all the way up, all the way down to a 0. But now that's negative 4.3 is our new start. All right. That's how this whole thing works. Okay, the last one is the D. Okay, now this is sliding up and down. And you've done this before with every other graph, whether it was parabolas or whatever's. A number at the end here, a number at the end is always a vertical shift. So same graph, cut and pasted up and down. Okay, how that's neat and stuff like that is you could do y equals sine of 2x, x plus 2. Now you got a second graph. And then copy and paste that. Plus 3. Okay, and you can make waves, and now I'm already seeing red, white, and blue, and I'm getting an idea for a flag-shaped graph. Okay, or maybe I'll just see what other colors it throws at me. Okay, but every time we change that, we've changed it from 5, 4, 3, 2, and this one was at about 0.5, but we can change it up to 1. Okay, so it just shifts the graph up and down. Same exact graph, same exact shape, up and down. Okay, so we talked about this in class, but in case you weren't in class, let me show you again. Now you will sort of see how this all goes together. Okay. So there is, geez, sorry about that. There it is. Vertical stretch, horizontal compression, the horizontal shift, and the vertical shift. So these two do not change the shape. These change the shape in totally different ways. Okay, so that's what you want to see. And again, we can go back a couple graphs. Not too many graphs. All right, so again, changing the vertical stretch is like that. Horizontal stretch, or sorry, horizontal compression is like that. Or stretch or compression, depending on which way you're looking at it. Okay, so that's horizontal, that's the B. This is the A. So each one does something different, okay? And I'll put all those together for you on one handy slide, and I will share that with you in class. Thanks for watching, you guys.